Hello everybody, Archit is back. These days I have been working with the Agentic AI and doing some research and development on my own. And recently somebody asked me a question on how non-AI engineers can really make use of the Agentic AI. So this is supposed to be a short tutorial on how everybody can start using the Agentic AI for their individual uses. And today I will be sharing how I have put together a very short uh, Jupyter Notebook tutorial, a code that you can run on your computer and really get started on the use of Agentic AI for doing some local PDF searches and then connecting that with the internet. So here I am using my personal Google Gemini account, and I will be walking you through on how to set it up and start using the AI agents provided by the Google. So before we begin, first thing you need is you need to have a Google account on Google Studios. So you will have to get the Gemini API key from this ai.google.dev, and you will need a Serper API key from here. Serper is basically a Google search API, and this gives you about 250 free queries, so you don't have to give any credit card information or anything just for this tutorial. So once we have this API keys from your Gemini account and your Serper account, we will start building the AI agents. And for the flow of this tutorial, we would be first creating a local document retrieval. So that's an RAG, and then we will be connecting it with the online web searches. And we will have a large language model, which is in this case going to be a Gemini 2.5 Flash. It's a LLM reasoning model, and we will be integrating the local document retrieval and the web searches with the LLM model. And we will see how the LLM model is going in your local PDF files and answering the questions that you ask from the local PDF file along with the online searches. So here I have given some very high level information on what is RAG. You can read through this in your own time. I will put the link to this code in my description. Here, it also explains what a local knowledge layer and everything look like. Here also I'm explaining the workflow, which is pretty much indexing the local document and then receiving a research question. So that's user, that is us providing it a research question. And then this research question will be parsed through an LLM agent, and the LLM agent will be deciding whether it wants to just answer it from the local embeddings, or it wants to use the Serper API key and fulfill the current information that's out online and answer our question. And based on all of these decisions, the AI is going to generate a up-to-date response and give it to us. So here I just provided this 5 workflow points to the Google Gemini image generator, and it has generated this visual for us. Here we can see this is the user, that is us asking us the question, which we will do very soon. And it goes directly to the research agent. Then the agent is going to decide whether it wants to do a local fetch from the local PDF embeddings, or it wants to go online and search. And then based on both information, it's aggregating and then compiling again with the LLM agent stuff, similar to a chat GPT, and it's going to give us a final answer. So in this case, we will need a couple of imports. And here I am initializing this agentic AI using the OpenAI libraries, because this OpenAI libraries are quite everywhere. So you can easily integrate your API framework using the OpenAI libraries. And here you can see these are the key files that I'm loading from my local drive. Then this little function parses the JSON files and loads in the right API key values. Here we can see the credentials are loaded, and here we are creating the client. So once the client is in, it has basically validated that your API key is accurate. and you have provided the base URL, which wherever you generate an API key from any provider like OpenAI or Gemini or any other LLM provider that you can think of, they will give you an API key along with a base URL. So you have to provide both the information when you're creating an LLM client. Now we will see what models we can access. So this is just going to be a quick list of all the models that are available on Google AI Studios. So here we can see the first one is Gemini 2.5 Flash and Pro, and there is this long list of all the models we can get. So for this tutorial, I am just going to stick with the free models I have from my Google account. There is definitely a usage limit. So hopefully I haven't exhausted the usage limit for today, which we will see. If that's the case, then we will just have to change the model and go with whichever is available for me. So here, first step was basically to load in all the API related information. So API keys, we initialized the OpenAI's client here, and we listed all the models that are up online. So once you get this response, it basically proves that you are on the right track. You have connected with the API server and everything. Now we are basically building a local RAG index. So this is going to use your laptop's resources like GPU if you have it. If not, then it's going to run on the CPU, which is usually time consuming. Now, in my case, I have a GPU. So basically what it's going to do is it is going to extract the text from my PDF. And in this case, my PDFs are basically here. Here you can see it's on home, desktop, archive papers. Now, these are the research papers that I have already published. So these are the local PDFs, which will, so I'm basically going to ask the LLM questions coming from these local PDFs. And you can see one paper is mid-air drone-to-drone charging for enhancing the flight endurance. And then second paper is basically a patent application on systems and methods for interfacing the natural intelligence with AI. And another one is also a long paper about the fusion intelligence. So I am going to provide these three papers to my code, and my code is going to create the vector embeddings. And on a high level, if you're trying to understand what this embedding means, you can think of it as some vectors. So you will basically see that your code is going to create these kind of high level vectors, which will be passed on to the LLM agent, and the LLM agent will be able to understand how the sentences and the words are put together in these papers. Here we can see there is this read PDF text. It is basically going to parse through the PDF, and then it's going to create this local RAG class, and there is a retrieval function here. All of this is going to be taken care of by the LLM agent. So we will compile this code, and we can see that it has made this weights here, and now we are connecting it to the online search. And this online search is going to facilitate the AI agent to use the online Google search resources to complete our answers. And you will see what I mean by that in the questions that I will ask to the LLM agents. So the online search is basically, here we can see it's going to the Google and asking the queries if it wants to fill in more information to it. Here I've also given that the question requires the up-to-date answer, but if the answer is not available in the local document or something, then it's going to go online automatically and look through the external resources. So let's compile this function here. Now is the time to tell the agent what tools it has available. So here, this is a very short tutorial. So I just have a local retrieval and the web search, like I said earlier, and I am telling the agent this is how it can interact with the tools. So we can see the local retrieval, and then I'm telling it the objects, the queries are type string. The free API has a limit, which is why I have tell the agent that it should only default the queries to 5. Otherwise, it can just keep on searching. And if you have connected your credit card, it can be a little expensive. So I'm specifying the tools that a LLM can use, and I am telling it as a system prompt, I'm telling it that the LLM agent, here the Gemini, is a researcher, and it can use the local retrieve tool, which is the local retrieve tool here. You can see that the names are same. So there is least possibility of any confusion for the LLM agent. Here, the local retrieve is a tool for it, for the facts search on the local PDFs, and then the web search. And then I'm also telling it in the final answer, it needs to summarize everything, provide the key points, and also provide the local citations and everything. Then I have defined the research agent and specified the role, and also specified myself as a user that I will be asking it a question. Now let's compile this. So it's compiled here. Just to make sure everything above is compiled. Yes. Now it's the time to run it. So here we can see RAG is a local RAG class here. I made an object, and then I am providing it the path to my papers, which is just to double check its home, desktop, Orchid Papers, user, desktop, Orchid Papers, Fusion Intelligence. So you have to make sure that the file names are exact. Otherwise, it's going to complain file not found, and it won't be creating the RAG embeddings, which are very important. So double check the file names. Now, it's going to definitely build from PDF. So it's basically going to build the embeddings. And then I am asking here, this is the main part. Here I'm asking the research agent, can you tell me what was the improvement in the flight endurance due to the proposed D2DC framework? And did any other research article cited the D2DC paper? Here, I have specified that I wanted to specifically use Gemini 3.5 Flash. There is on the Gemini free, the Google Studio free version, you have a rate limit for everyday API usage. So I think I have exhausted for 2.5 Flash. That's why I'm using it on 3.5 Flash. I don't have any specifics about which one is better. I think they both are just similar in hallucinating. So we will see how it does in this case. Here we can, back to the question, it was about what are the improvements in the flight endurance due to the proposed D2DC framework. Now, D2DC is a very specific word used in my paper. So if the embeddings are done correctly, it should be able to identify that D2DC means drone-to-drone charging. And then it's going to also look through the paper and find out the improvements, which it says that 28.24% improvement in the mission success rate. That's all information coming from the paper. So let's test it out. Here I am running it. Here it says, based on the provided documents, here is the analysis of the improvements in the flight endurance from the D2DC framework. So it's summarizing it. It's the drone-to-drone charging framework in the mid-air recharging paradigm design to address the range anxiety. Yes, that is true. So the paper says in multiple places that it's meant to address the range anxiety of the UAV swarms. And back to the answer, it says the key points here. So as we expected, it is saying that 10% more distance compared to the regular drone feed. So yeah, it is able to cover 10%, and these numbers are indeed coming from the paper. So here we can see that in the abstract, we have clearly specified that there was two improvements. One was the 28.24% improvement in mission success rate and 10% increase in the overall flight range. So it successfully pulled this 10% increase in the overall flight range from the local RAG and compiled everything. And here also you can see that there is this number of 28.24. So basically, it went through the local embeddings successfully and identified the key improvements or the key contributions of this paper. Now, it says citations by other research articles. Citations part, this in particular uses the online search. Here I am asking it to see if any other researcher has actually read through my paper and tried to cite it. So online on the Google Scholars, I did see there were a couple of citations, but here it says there is no record of other research articles citing it. So this is certainly not very accurate, but I can see why it happened. And it happened because we have specified the rate, the search limit here default to 5. So since this D2DC paper is not really on the top of the Google searches, what happens is the Serper API is only going to search for this keyword drone to drone charging paper for 5 times at max. And if it don't find any references for just the first 5 searches, it is going to give it up. And that's good for us because you don't want to put your credit card and then have the API keep on running and keep on billing you. So it says no record found, and I'll take it. I'm not going to ask it to do a deep search or anything. And here it's giving me the local citations, which aren't very much detailed, but Gemini, I wouldn't expect it too much. Now let's ask it another question. This question is about my other paper of fusion intelligence, and let's go to the paper real quick. Here we can see it has multiple authors. So I will be asking Gemini in this paper, what are Urchit Jaiswal's specific contribution and which facets support them? So here I'm going to ask a very specific question about my contributions. There we go. So Gemini models aren't my favorite ones, but here we can see that 2.5 gave us a better answer than 3.5. Then in the citations part, remember in the beginning, we did specify the in the prompt that it has to provide us citations. So here we can see it did stick to this fundamental framework we have defined for a system as a research agent. We did ask it to provide a citation. So it did the local citations and the web citations down below. Here we can see it went through this Serper API. So the web citations are coming actually from the Serper API compilation. Here, confluence of natural and artificial intelligence for enhanced. So let's click on this link and see if it is working. And it takes us to our same archive where where the paper is also uploaded for a copy. So the link was correct. And it has also successfully found my Google Scholar profile. So let's see if the link is correct. It is. It is. Okay. There I am. It is pulling up my Google Scholar profile. Now, let's see what is the last one. Last one is a ResearchGate publication. Let's click on the last one. Security check. So hopefully this link is also correct. And it is. It is. Okay. So 2.5 Flash is working fine. Now we can give another chance to 3.5 and ask it, did any other research article cite the drone-to-drone charging paper? Let's see if it says none. Right, it is taking long. Hopefully it should do some work. This is longer than I expected, but in the oh, there we are. Huh. In fact, this one, it seems like it really did some work. So it not only summarized the PDF we provided, it's also saying there is no documentation or mention of other research articles, but that was the same limit to the 5 searches. So that's okay. Local references from the local PDF, it did try to put some summary here, some web searches, web search results. And then here we can see there are some more web citations it has compiled. So let's see if the links are accurate. And looks like yes, there is. So I think this one might have cited my paper because I did receive a notification while ago saying there is a citation. So it could very well be a real one, but we don't know. So let's go back to the search. we can ask one more question. I don't think I'll be running out of the tokens for today. We can ask something like, what were the key points and what were the key contributions of fusion intelligence paper? Yes, there we go. It's an autocomplete question. Let's see. See, it's running. It says none. This is a very typical Gemini thing, like I said, so we will have to rerun it. And if it's taking longer, expect a better answer. None. All right. When it does that, I'll be changing the model to 2.5 and give it another chance. It should do something. Okay, there we are. It says key contribution of fusion intelligence paper is introducing the fusion intelligence, and it did actually went through the paper. It looks we have covered specifics about the bees and ants and everything, and how we can utilize their characteristics to compute to solve a problem, an AI problem. So it is doing something with the summary, and we can later on verify how much accurate it has compiled the information. But looks like Gemini 2.5 is doing a better job than 3.5, at least with this local RAG application. So just to summarize everything we did in this short tutorial, I'll definitely put the link to this notebook in the description box. It will be a link to my GitHub account. But to summarize everything, we basically took all the local documents on the local hard drive and then compiled it in the embeddings. Then we used this Google's Gemini and the online search feature, made it as a tool for the AI agent to use it. And we specified the responsibilities we specified the tools, and we specified the responsibilities of the AI agent, the research agent, and let it use the tools. And this is how we got all the answers. So you can definitely do more exciting things with this AI agents. This was just a startup. If you wanted to make it more complicated, more advanced, then you will have to basically specify more tools here. And there are different ways how the tools can interact with one another. So feel free to dive deeper into it. And if you have any questions, you can also put them on the comments, or you can directly reach out to me over LinkedIn. That's it for today, folks. Hope this tutorial was helpful, and always let me know if you have any questions or wanted to see some more videos related to this topic. For now, thank you for watching, and we'll see you in the next video.